Let's talk about the options for repairing an all-aluminum radiator. And when I say all-aluminum, I mean that both the tank, or the two tanks, and the cooling tubes are made from aluminum. In some cases, the tanks are plastic. So here the tanks are aluminum, and so essentially there are three different options for repair. One is solder, the other one is braze, and the third is epoxy. These radiators are manufactured, they're brazed together. There's the header plate here into which these tubes are inserted, and then everything is brazed together in an oven with an atmosphere, and then there's a weld that occurs. And I think the weld is possibly the reason for the leak here, because I think what happens is when the weld is made, it overheats this area here at the end of the weld, and then the braze fails. At any rate, there are two ways to solder the radiator. One is by using the Stic-Tite system. It's of course a soft solder, low temperature, about 350 degrees Fahrenheit. The other option is for Muggy Weld, which is also a soldering option, and that is called Super Alloy 1. And the third option is the brazing option, again from Muggy Weld, that's called Super Alloy 5. And again, it's filler wire and flux, but that's a much higher temperature, 600 degrees. In this particular case, what I'm trying to repair are the junctions between the tank, or the header plate, and the cooling tubes, and all the way down there. So there are pinhole leaks. I don't think that the soldering, or definitely not the brazing options, are going to be suitable, because I don't really believe I will be able to control the flame in such a deep cavity in an appropriate manner without melting all the cooling fins and possibly causing more damage to the other junctions. So I have chosen the epoxy approach. This is the epoxy that I'm using. It's from JB Weld. You can see that this is a high heat epoxy, 550 degrees Fahrenheit. The strength is just under 5,000 psi. Of course, the solder and the brazing options are much higher, but you know, the radiator is operating at maybe 15 psi, so it shouldn't really be a problem. The issue with epoxy, generally speaking, is that the expansion rate of the epoxy is different from that of aluminum, and of course the radiator is constantly heat cycling. But again, we're talking about repairing pinhole leaks, not a crack in the radiator, for which of course I would use solder or braze. Or for example, if I had a crack right here in the front, at the very bottom, I think I would be better off using a soldering methodology there. But all the way down in there, I really don't believe I can control the heat that well. At any rate, this is a two-part epoxy. It has a really long cure time, as opposed to another product from JB Weld, which is actually specifically advertised for radiator repair. But that product, and again, it's a two-part epoxy, but it's more like 5-minute epoxy, and the working time is very short. The reason I want something that has a much longer working time is because when I try to fill these joints with epoxy, I have two things working for me. One is the capillary action. When you mix the epoxy, it's relatively thin, and by capillary action, it's going to actually suck into the junctions, deep into the pinholes. And another thing, of course, is that's assisting me is gravity. I will be making the repair in this orientation, so gravity is also going to pull it down. I mean, with capillary action, of course, it even works upside down, but I would like two of those physical properties to work for me, so that's what I'm going to do. One very important thing to keep in mind when you are attempting an epoxy repair of a radiator is that the radiator has to be completely dry, inside and out. And so what I've done previously is I've blown hot air through the inlet, out the outlet for a period of time. Make sure I get as much water as I can out of the radiator. Of course, I dry the radiator from the outside, and then I actually left this thing in the sun for a couple of days to make sure, with all these things open, to make sure that all the water evaporates and the radiator is completely dry inside. If there's any moisture inside the radiator, your epoxy is not going to work, period. Another thing that you need to do to make sure that the epoxy repair works is to prepare the joint well. And for that, you need some chemical cleaning to make sure that you degrease the joint. The best thing I can recommend for using there is either acetone or isopropyl alcohol, like 91% or higher. And or you could use something like this, QD electronic cleaner. I would not use any type of brake clean. Any type of chlorinated cleaner could hurt thin aluminum, could actually cause problems in that joint, so I would not use that, but this is not chlorinated, so it's fine. Again, acetone is the best, or alcohol is really what you want to use. Another thing that you need to do is then prepare the joint mechanically. So what I'm using are these small stainless steel brushes. Regular steel is not going to be a good thing in this situation. For aluminum, you want to use stainless steel, just like when you weld aluminum, when you prepare the joint, you want to use a stainless steel brush. It's only been used on aluminum, nowhere else. I will put the dimensions of these things in the description. This brush, I believe, is under 2.5 millimeters in diameter here, and these things wear pretty fast. So and they're anywhere between $3 and $5 each. So you have to kind of think how many of these joints you have to repair. If it's all of them, I don't know. It may be better to get a new radiator, and because these brushes, a couple of them only last maybe for 2 or 3 of these cooling tubes, and then you have to get new ones because that's what happens. They basically just disintegrate. So you use the brush to kind of scour the junction between the cooling tube and the tank. But that's not really enough. What you want to do is then get deep into this crevice. And how do you do that? The brush is just too thick to do that. What you want to do is take the brush, and what I did is I smashed the end of it. Hopefully you can see this. I smashed it with a hammer to make it kind of look like a screwdriver. It's just kind of wide and thin. And so then what you do is you get into the joint and you trace the joint like this with this little blade that you've made, and just keep doing it for a while until you get all the debris out. You keep blowing the debris out, and then using the regular brush again, this again. It takes a little bit of time to prepare the joint well to make sure that the epoxy sticks. It's a good idea to use some compressed air to blow this out. Even better if you have a blower like this little blaster, Air Force blaster. It works really well because it has high volume and decent pressure to clear the joint. So that's pretty much all I can recommend as far as the prep. When you apply the epoxy, it's a good idea to have a little toothpick like this. Actually, it's a long one. And so you can see the marks here. This mark designates the width of the entire radiator, right? So what I'm going to do is I'm going to apply it from the epoxy from this side. So once I mix it, just pick up a little bit of the epoxy on the tip, and I press it into the joint, right? And so I know that once I've gone to halfway point or just a little bit beyond, I'm good. Then I can flip the radiator around and do it from the other side. One thing you can try possibly is introducing a little bit of vacuum into the radiator to suck the epoxy in. I personally didn't do that because it's making me nervous, that whole idea, because when you do this, the epoxies may tend to, and it also depends on the size of the pinholes that you have, but you may actually be able to pull the epoxy inside the radiator too far, which is not a good thing. It might even block one of the cooling tubes. That's not good. You could foam inside there because there's gas in the epoxy when you introduce it initially, and it degasses as it consolidates. But you can try it. I would not use high vacuum. So for example, I would not go over 10 inches of mercury, probably much less than that, even 5 inches of mercury, just for a very short period of time. Maybe apply the epoxy, then apply the vacuum for, I don't know, 30 seconds, and then discontinue the vacuum. The way you would do this is, if you have a vacuum pump like this, if you have a plug that has a hole in it, you can buy one or you can make one. Just if you cap off the inlet and the outlet like I showed you in the previous video with these plugs, and then maybe use a clamp, you can introduce this plug in here. So of course it has to be sized correctly. and then hook up your vacuum as follows. I mean, if you have a little bit of a gap, you can put tape on it and then you'll create a seal. Remove this cap, put the plug in, create a vacuum, hold it for 30 seconds maybe, and then discontinue. You could do that. I'm not doing it because, again, like I said, I'm going to rely on capillary action to get into the pinholes. Let me show you very quickly what the repair looks like. I've done a couple of these. By the way, I do one cooling tube at a time because I want the epoxy to stay as fluid as possible. So I prepare the joint and I do one cooling tube. So you can see that I don't really have that much epoxy there. More is not better. You don't want it to have it too thick because it can crack. I want it to kind of work with the aluminum, stick to the aluminum, and bend with it as it expands and contracts. So just enough just to make sure you fill that crevice, but no more than that. So it's a pretty neat looking repair. The epoxy, especially these epoxies that take a while to cure, do generally very, very well with glycol. They resist glycol, and as you can see, it does say that this is okay for radiators, so I'm not really worried about any kind of a chemical incompatibility. One more thing I would like to demonstrate is how I mix the epoxy. There's a little bit of a trick that I use, and I use, instead of using a stiff piece of cardboard, I use wax paper, and I'll show you why in a second. Sorry, I misspoke. It's actually parchment paper. You don't want to use wax paper. This is much better. So parchment paper is what I use. So as you can see, I use this parchment paper and a little mixing stick. It's kind of like a lollipop stick that I squirt the corners off, and the reason I do that is because it's much easier to kind of consolidate the two parts that you're mixing when you have a flat edge. But you will see that in a minute that you have another problem as you do this, because the epoxy sticks to this, and how do you get off of it? So let me show you. So this is a tip that allows you to reuse this tube. That's how much I squeeze out for one cooling tube. Oh, you know, this is interesting because the proportions seem to be a little bit off. So what I'll do is I'm going to segregate a little bit of this to the side. That does not look correct to me. Somehow it's squeezed out more on one side than the other. Anyhow, you can always remove that. It's not a precision operation. Mix it up. So you can see as I do this, there's stuff stuck to the mixing stick, and you know, I would have difficulty dealing with that unless I could pick up my substrate and actually wipe the mixing stick on it and continue the mixing. Again, I can repeat the process. Okay, so at this point we're good to go. I can apply the epoxy with a toothpick. I'm not going to show you how I do that because it's very difficult to film. But I'm just going to pick up a little bit of this and go at it.